A pulley is an example of another type of simple machine. There are many different kinds of pulleys available. Here's a single pulley. Here we have a double pulley with a hook on both the top and the bottom, and both of them turn independent of each other. And here's a triple pulley. And so we'll look at some examples of how we can use the pulleys and some measurements we can make as well. In order to support the pulleys, we can set up a support using a meter stick and some clamps. And so I've taken some clamps, put the fixed jaw on the bottom, and then you can just clamp the meter stick tight. And now you've got a fairly sturdy stand in order to do measurements with the pulley. So let's put a simple pulley on here. We'll use the same hooks that we use for the lever, just some wires that slip over the meter stick and from which we can then hang a pulley. So we'll put a single pulley on here, and then I'll take a piece of string and put that through here as well. And then we can use a pop bottle filled with water with a hook attached to it as then a weight that we're going to lift with our pulley system. Now, because we don't have a lot of clearance here, it's best to set this up so that we have the two supports on two separate desks, and the space between then that we can use for lifting things from the floor. So here I have a 2 kilogram weight, or a 20 Newton force then, being supported by the string and a pulley, and at the other end I have a spring scale to measure the actual effort required to balance the load. And that effort is also 20 newtons. Now, why is that? Well, when we have a single fixed pulley, as we have in this case here, all that the pulley does is changes the direction in which the effort is being applied. So the whole load is being supported by this string. And the pulley then changes the direction in which the effort is being applied at this end here. Now we can change the position here by suspending the pulley from the string and attaching now the load to the pulley. And if I now place my spring scale on one end of the string, I find that my effort required to balance that is approximately 10 newtons. In other words, it's half of the load that I have attached to the string. Now, if we look at the system here, notice that I've got two strings now that are supporting the load. Both of these strings are supporting the load equally. And we can measure that by placing another spring scale on here. Note that both spring scales are measuring approximately 10 newtons. So in this case, we have two supporting strings, and so therefore each of them supports 1/2 of the total load, or 10 newtons. Here I have two pulleys, one fixed pulley, the other a movable pulley. The one end of the string is attached to the movable pulley, goes over one of the pulleys on the fixed one, over one here, and is attached to the support at the other end. Now, what effort would be required on here to move the load up and down? Well, let's measure it. the spring scale reads just between 6 and 8 as I move it up and down. Well, let's analyze this system. How many different strings do we have supporting this load? Well, we now have 3. This one, and this one. So we've got 3 strings supporting the load. The load is 20 newtons. 1/3 of that is 6 2/3 of a newton. And so, indeed, we're measuring about between 6 and 7 newtons on this particular scale. Now, notice as well that when I lift it up, I have to move my string 3 times as far as the load actually moves. And that's where I get the mechanical advantage. Stringing up a pulley system with multiple pulleys is no easy feat. You'll find that it's not easy to get all the strings held in place properly. But here I've got a system with 2 pulleys, one of which is fixed, 2 pulleys on the fixed pulley, and 2 pulleys on the movable one. Okay, so let's begin at one end of the string. So this is attached to the movable pulley to which the load is attached. Goes over the 1 pulley, over the 2nd pulley here, over the 3rd pulley, over the 4th pulley, and supported then at the other end on our meter stick support. Note, I have to move the string through a long distance in order to move the load up and down. How many supporting strings do I have? Well, we have 1, 2, 3, 4, 5. So that the actual effort required then to pull this load up should be 1/5 the load. So 1/5 of 20 newtons is 4 newtons. So let's measure that. We'll attach the spring scale. This is a 5 Newton spring scale. And let's just get it to an equilibrium position. And indeed, it's measuring 4 newtons on here. So the actual effort required to support a load using a pulley system is dependent on the number of supporting strings that we have, as we see from this demonstration. Multiple pulley systems have been used in the past by farmers to bring hay into their barns. They've also been used on the old sailboats to raise and lower the sails, so that you can then use a smaller effort to lift a heavy sail into the wind.